So we have a problem here. It's taken from chapter 4 of Chemistry for Engineering, second edition by Brown and Holm. The problem states that in an experiment carried out at very low pressure, 1.3 times 10 to the 15 molecules of hydrogen are reacted with acetylene to form ethane on the surface of a catalyst. We are asked to write a balanced chemical equation for this reaction, and we need to find the number of molecules of acetylene consumed. This is a stoichiometry problem. So to give a little background of the reaction, the reactants involved are hydrogen and acetylene. So under standard conditions, these are gases, and the product of this said reaction is ethane, which is also a gas. So to look at this problem, consider that this is an experiment which is carried out very low pressure and that there is a presence of a catalyst. So why did this problem emphasize such? So let's consider the properties of our reactants. We have hydrogen, which is a light gas, and acetylene. So acetylene is a safe gas, as it is called, under low pressures. However, as it reaches certain or specific high pressure, then it tends to become self-explosive. Thus, this experiment, so imagine you're the one performing it, it needs to be carried out at very low pressure. And then there is a catalyst. So what do we call this reaction, by the way? So we can actually call this reaction based on the reactant. We have hydrogen. So acetylene is being hydrogenated and that there is a catalyst. So this term for the reaction is called catalytic hydrogenation. And notice that it states that there is a catalyst involved. So some of the catalysts are listed here. They are usually bimetallic or two metals, which is used you to carry out this reaction in a reasonable rate. Because although hydrogenation in general can proceed without catalysts, it may require a higher temperature to favor formation of products, and that would be critical or that would be risky for this reactant here since acetylene might reach its critical pressure. So moving on, so another reason for the need for catalysts is that because we need an enormous energy to break down the bonds of acetylene, a catalyst would help the reaction to proceed. Proceeding to letter A, we need to write the balanced chemical equation. So everything, well, almost everything except the answer is given, so we can say that this problem is half solved. So counting the number of elements per side, we have 2 carbon left, 2 in the right. We have 4 hydrogen here in the left, but we have 6 at the right. So what we can do is look at the coefficient and we can actually apply 2 here, multiply 2 to get 4 and add up with this. So we have 6 hydrogen on both sides and that would give us the answer for letter A. This is the answer for letter A, our balanced chemical equation, which we will need to be able to calculate the number of molecules of acetylene consumed. So what are we given, or what is another information that we know of this reaction? It states that we have 1.3 times 10 to the 15 molecules of hydrogen. So this is the value that we will be used as basis for calculation of the number of molecules of consumed acetylene. And we do know, or this concept or this problem requires us the concept of Avogadro's number, which actually technically requires us the value of Avogadro's number. So we know that we have 1.3. Okay, let me just use a different ink color. And we know, or we do note that Avogadro's number is 6.022. So for every mole of a substance, that's 6.022 times 10 to the 23 molecules of that substance regardless. So that's also just a trivia. That's why it's called the chemist's dozen, because for every mole of substance, that doesn't change. That value is constant, so it's basically a conversion factor. So now that we have the end unit mole, we now proceed to look at the back our equation. What we're looking for is the molecules of C2H2 or acetylene. And what this equation tells us that if we have two hydrogen, it's equivalent to one acetylene. So 2 moles of hydrogen, or let's say 1 mole of acetylene, is actually equivalent to 2 moles of hydrogen. And now, from this, we already have our answer, but what we lack is to be consistent to the units. So 1 mole of the acetylene, or 1 mole of that substance, so just multiply it back with the 6 point, or the Avogadro's number, since that's what the problem is looking for. Okay, so let's look at the units. So our expected units is molecules of C2H2, and we have arrived at that. So cancel molecules H2, mole, and this is the molecules acetylene. So notice that you might wonder, we already divided by molecules. We have to multiply it again, molecules. Why don't we just divide it by 2 right away? Well, it's because this problem is pretty simple, but we have to make sure that, or we have to remind ourselves that this method is simply to ensure that we are dimensionally consistent and that we are able to come up with the right units that the problem is asking for. So using our calculator, we can get the number of molecules of acetylene consumed, and that will give us, so that's 6.5 times 10 to the 14 molecules. And that's it. Our problem is solved. So I hope you learned something, and thank you for watching. Leave a comment if you've got any questions or reactions, recommendations. Thanks.